This is part F of the same question, of the same exercise, on the same question. Oh, that was what we're given. Did this normal bit over here. That gave me this bit. Tried to factorise this denominator, took a u out, cancelled the u's, moved the 2 through the integral sign, and I'm left with this. And the challenge at the moment is to integrate this thing here. I'm just ignoring the 2 for a minute, that's not part of the integration. If you're ever trying to integrate a fraction, there's another, what I call red box rule, that's really, really useful. If you are integrating a fraction where you've got some function on the bottom and the top of the fraction is the derivative of the same function, the answer is log of the function on the bottom of the fraction plus c. You can put brackets around there if you want to. So what I will do now is I'll show you how you can use that in this example. But if you're ever trying to integrate a fraction, always ask yourself, does it fit this? Or can you fiddle it so it will fit that? Can you make the numerator, the top of the fraction, equal to the derivative of what's on the bottom of the fraction? Because if so, the answer is log of what's on the bottom of the fraction. And if we look at what we had a minute ago, the example I gave you in question A, it fits here. Here, the derivative of the bottom is just 1. So it actually does fit here. It's what we're looking at is a generalisation of that one there. So, with this one here, at the moment, is the top of this fraction, is 1 the derivative of 4u plus 3? No, it's not, okay? So it doesn't fit the rule. Well, let's just make it so it does. Let's put a 4 there, because 4 is what you get when you differentiate the bottom. Do we agree? That now fits this rule. The top is the derivative of the bottom. Well, what have I just done to this expression here when I've rewritten it like that? What have I actually done? By sticking that 4 there, I have done what to this expression to make it into this one?
Times it by 4.
I've times it by 4. So to make it back to this one, I need to divide it by 4. Do you now agree that that and that are the same? But I've fixed it so that this now fits this red box rule here. Now I mustn't forget that 2. That 2 is actually still there as well as a timesing thing. But now if I do this integration here, if I do the integration that I'm putting, just to make it clear, inside that orange box there, I have my function, my f of x is 4u plus 3, and that is a derivative of it. So the integral inside that orange box will be, according to this red box rule, log of whatever is on the bottom. Then I've still got these 2/4 here. What's 2/4 normally said as? 2/4 is half. So I've still got that half there, and I've got my plus c. Now, if we're finishing off this question, I then need to change that u back into an x. And u in this question, we had it earlier on, u was equal to the square root of x. So finishing this question, I've got to change that u to be a square root of x. Put the half in, put the plus c in, and then it's there. But the key thing here is this red box rule here. Anytime you're integrating a fraction, it's always worth checking. Can you write it as function on the bottom with its derivative on the top?